Hi guys, welcome back to our channel. In this video, I'm going to explain the different types of operators in Python. I have already uploaded one video on operators in Python. This is just like a continuation of that video. I can also say that this is part 2. Part 1 I have already uploaded. If you haven't watched that video, please watch that video before watch this video. And I will also provide link for that video in description box. Please check out there. And before start this video, if you are new to this channel, please do subscribe to our channel and hit the bell icon so that you will get notification whenever we upload a new video. And also please like this video, it will motivate me to do more videos. Thank you so much. Back to video. Logical operators. Logical operators are used to combine conditional statements. Conditional statements means nothing but these comparison operators only. That means here we are comparing only one. That means either we are comparing a greater than b, a less than b, a greater than or equal to b, a like that. We are doing only single comparison here. But if you want to do multiple comparisons, then how we can proceed? Here we have three types of comparisons are there. One, and or not. And means in our comparisons, if you take two conditions, like for example here I am taking a is equal to 10 and b is equal to 20, like okay, here first my condition is a greater than b. This is false, we know that. As for our this comparison operations, we know that a greater than b is false because 10 won't be greater than 20. So this is false statement. And next one I am saying a greater than b. This is true, we know this, okay. This only single comparison, that means we are only doing single comparison. But here I just want to do two combination at a time, two condition at a time. So that time we use and or anything we use, either we can use and or. Here difference between and or is, in and both must be true to become a true, that means to give the output as a true. In false, when both are false, that time only it will be false, remaining true. I will explain this very clearly with example. Okay, first we will see and operations. Okay, here you can see, we know that a greater than b is false, right? And this a less than b is false. But what here I am doing, I am by using and I'm trying to find it. It will give false. Why it will give false means this was true, this was false, and this was true. Here false true, what and will be give false. This false and true, it will give false. Whenever both are true, like for whenever both are true, that time only it will give true. Here a not equal to b, this is true. So what here, true and true, then answer is true. This is and, when it is and, okay. But this is about and, whenever both will be true, that time only true. If it is anything is false, like for example in this case, if I take instead of this is true I make false, then it will give false. That means both condition need to be satisfied to get, both condition need to be satisfied, then only will it get true. Here you can see, whenever true, that time only true it giving, remaining times is false. Same like if we go for or, if for example I am taking this, here we know that already. What we know that this condition is false and this condition is true. If instead of and I will use or, then we will get true, because this one is true, so it will give true. True and true, true and true will give true or true. False or true, this is false or true. False or false or true is true. Here you can see, whenever false false is there, that time only false, remaining all time it will become true. Okay, like if you false or true, true. If I make this also false, then we will get the false. In false, only when both need to be false, that time only it will become false. In true, only both will be become true, that time only it will become false. It will become true. Okay, this about this. This will give true. These are the different types of logical operators. This is just an what exactly how they are getting. We need to not by head and table. Just remember, whenever both are false in and, that time only it will both are true, that time only true. Whenever we take in our condition both are false, that time only false, remaining all time whenever true is there it will become true. Whenever both are true, that time only true in our and condition. This is logic gate. We need to know this truth table to understand this. If you don't know this truth table, then please learn these truth tables of and or, and not is nothing, just like it will reverse. If it is false, true, true, false, so nothing is there. There is no, just it will reverse the condition. If it is false, then it will give the true. If it is true, then it will give the false. It will make reverse. In my previous example, I have explained this one. If I have only one condition, how we need to do. But if we have multiple condition, here I am making another column is alive equal to no, and but here my condition is and, means this age is must be greater than and, means this condition must be true, and alive equal to also yes, then only a person can, then only a person can be. Here we need to use equal. I have used equal. Equal means assigning. We are not going to assign in, we are just comparing here. So here he can't do, he can't vote because he was died. If person is dead, how he can do vote? So he also not eligible to do the vote. For example, if I mention yes here, then he can vote. But if the person is less than 18 years, then he can't vote. That means two condition it will be checked. First, it will check either a person having age more than equal to 18 or more than 18, yes. Then and alive equal to yes, it will, he can vote. Okay, because those both conditions are satisfied this person, then he can vote. But if the person is not no more, no, then he cannot vote here. This one example. And second one, this is if you want to find the greatest element in three we need to find the what is big element in this three. I have right. First of all, I am comparing this a with this one and nine, and this a is the one. If this value is greater than both, then it will become big value, right? In this three, for example, if a is greater than this c and b, then only it will become big value. What I'm here, here also I am doing that only. A greater than b and a greater than c. That means a greater than means 10 greater than 20 and 10 greater than 30. I am comparing this one with 2. So I am comparing first that. If that is satisfied, then print A. Next, I am using elif. These conditions are conditional statements. I will explain these things in coming videos, but just understand logic. If here just next time what I am doing, I am taking b. Now I am cutting b greater than a and b greater than c. If this condition is satisfied, then it will give b as a big value. If the both conditions are not satisfied, then c must be greater than. So if I print this, we will get the value. We will get the value as c is big. As we know that c is big value, right? 30 is big value. If I change this to 100, then a must be big value, like that. If it's change to 2000, b must be big value. If I change this to any more than this value, then c will be that. Just it is comparing. So if you want to comparing more than two conditional statements, then only we need to use logical operators. Here the definition is that one. Logical operator used to combine conditional statements. Here I am using two conditions, here also and here also. This is all about logical operators. Next one is membership operators. Membership operator are used to test if a sequence is present in object. A sequence is present in object, we can check. In Python, everything is considered as an object. A string and integer or list tuples, we will discuss about that. Those are all considered as an object. So if you want to check either a sequence or digit or character is present in the object, by using membership operator, we can easily find out. In membership operator, there is two types of operators are there. First one is in and second one is not in. In, it return true if value or variable is found in the sequence and false otherwise. If the tested value is present in sequence, then it will give the true. If it is not, it will give the output as output false. Same not in is vice versa. It is different. Like it is reverse. It return true if value or variable is not found. If it is found in, it will give true. If not found, then it will give true. It is like vice versa. It is a difference. For example, if we want to find that item, we can use in. If you don't want to find and you want to continue your code, then you need to use not in. Let this will understand by using below examples very clearly. First, let's see understanding in operator. Here I have taken RNR things. This is, we know that this is string variable, right? In string variable, I just want to find this sequence. This is sequence RNR. This is sequence. If I check this, RNR is present here, so it will give true. So we are using in and this value or variable. This value is present in this, so it will give true. If I add anything that not matches, then it will give false. So here below also I have given that. I have random character I have given here. The sequence is name. That name is not present here, so it will give false. If I enter here some name, then it will give true also. If I just space this, it won't give. It also give true. So the space also not matter. It will take the string like this one. If just check like that, if this like this, it won't give true. Here name is present before, that's why it give. The spaces are not calculated here, so this is false and this is true. And coming to not in operator, RNR not in S, it is true. It is false because it is there, but according to the not in operator, it will give true whenever that string or the tested like which you can say sequence is not present in object. But here this RNR is present, so it will give false. Here name is not present, so it will give true. This is we can use anything. Like for example, we want to find 1 in 1 2 3. Okay, we cannot find like this. Either we need to use double quotes here. It will give true because this value is present here, so it will give. If you mention anything not present, it will give false. So I will give one real-time exam where this membership operator is useful. Not only in case, this is one of the example and this is real-time example. Here this is, we can say, student. This is one student name. This is one student name and this is list of students. That means total list of students, students list. Total list of students are present in this college are these many. 4 members are present in this college, and I just want to find either this person is present in college or not. That means is this person name with Ram. Ram is present in this college or not. In this situation we can use in operation, that membership operation. That is student name. Just I need to change this because I have changed it here, right? So I need to change here This don't worry, this if and these things I will explain in coming videos very clearly, but just now just understand the logic how it will go, how what exactly use of in and not in is. So here my problem is I need to find that this particular student is either present in this college students list or not. So I can use this in operation here. I am using either this particular student is available in student. If it is in, then it will give true. Whenever it's true, it will show s. S means that the person is available. If it show means the person is not available. If I mention here it giving s, that means this ram is present in here. If I give any space here like this, it's no, because ram with space there is no person is available here. If here also space is there, then it will give s. Instead of ram, if you write like John, then also it will give actually I have entered here s. This is a real-time use of in operator. We can use anywhere, but just remember that in operator will be just find out either this sequence is present in this object or not. That object is not only string, it might be list, or it might be like tuple dictionary, that might be anything, but I have taken string here. You can update that, but why I'm explaining only string big, because I didn't explain list and tuple there, so that's why I have taken string here. So this is all about membership operators. Next one is identity operators. Identity operators are used to compare the object, not if they are equal, but if they are actually same object with the same memory location. I think little confusion is there, but I will make you very clear. Give me 1 minute, I will make you very clear. Before starting this identity operator, I will give small difference between what identity operator checks and what memory this membership operator check. This in previous we have discussed that. Actually, the membership operator will check either that sequence or this sequence of characters are present in particular object or not. Here, if you see this, what this membership operation is do, taking this sequence and it will finding the either this variable, this sequence is present in this object or not. If it is present in this object, then it will it will return the true. If not, then it will give the false. Overly what we can understand here, that membership will be find the either that object or person. If we here take a person is present in that particular group or not, it will check. If it is the person is available in group, then it will give true. If it's not, then it will return false. That is membership operators do. But coming to identity operators are won't work at value level. It won't check about your value, either that value be same or not. It won't be check that. It only check that memory location of the that particular value. For example, I will give example, then you will get clear understand. First I am creating a variable name1 equal to with rnr things. I will create same same value with different variable. This way this is different variable and this is variable. These are both different string variables. And if I apply this name1 is name2, then it will give false. They are looking like identical, but they are not actually identical. If you want to find the memory location or memory address, we use in Python id inbuilt function. If you pass name1 here, you will get id. This is the background id. Whenever you call this name1, the compiler will call this id only, then it will get the this rnr things. If you check same id for name2, then if you compare here, these both are different. There is no same is there, because they are different. That's why it will give false. For example, if you create a name3 equal to from name1, And if you try to apply that membership operator now, not membership operator, that identity operation at name2, not name2, num3, then it will give true. Because if you try to find memory address of name3, we already know name1. Here you can see this name1 identity, that memory address and this memory address is same, so then only it will give true. Okay, these both are identical, means the memory address of the both variables are same, so that time it will give likewise if you enter name1 not is not, I think is not, we need to use is not name2. It's true because name1 is not identity to name2, because the both memory address are different, they both are tagged to different address, so they are not. This is about identity. Here in definition also it's showing that only. Identity operators are used to compare the object. It uses to compare the object. Name1 is string and name2 string, both are objects, and not if they are equal. It will give true not if they are equal. It will return the true when they actually same object with the same memory location only. Whenever the both variable having same memory location, that time only it will give true. That means it won't compare the values at all. It will compare memory address. Whenever the memory address are same, then it will be true. That all about identity operator.